Hello, welcome to another video. In this video, we'll see the topics stress distribution in soil and compaction. If you see the first question, they have given that uniformly distributed line load of 500 kilonewton per meter is acting on the ground surface. So based on Bosnia's theory, they are asking to find out the ratio of vertical stress at depth 2 meter to that of 4 meter, right below the line of the loading. So they are asking us to find out the ratio of vertical stress at 2 meter and 4 meter right below the line of the loading. This is the very important question, important point, below the line of loading. So we'll write on the given. Given is Q equal to 500 kilonewton per meter. So if we draw the diagram, since this is a line load and it is acting on the ground surface. They're asking us to find out the ratio of vertical stress. Let us ratio of vertical stress is that equal to 2 meter and let this be 4 meter. So there is no eccentricity, therefore solution. Value of x is equal to 0. No eccentricity. Means they are asking us to find out the vertical stress just below the line load. So we are taking x is equal to 0. According to Bushnell's theory, the equation of stress under line load is given by sigma z is equal to 2q divided by pi z into 1 by 1 plus x by z the whole square, again the whole square. Here, since x is equal to 0, we'll take it as 2q by pi z 1 by 1 plus 0 by z whole square, which gives you 2q by pi z. Okay, so at depth 2 meters, z is equal to 2, which gives you 2 into 500 divided by pi into 2, 500 by pi at z is equal to 4 meters, which gives you 2 into 500 divided by pi into 4, 500 by 2 pi. Now they asked us to find out the ratio of eccentricity ratio of vertical stress with respect to 2 meter and 4 meter. Therefore, ratio which is equal to z is equal to 2 by z equal to 4. 500 by pi by 500 by 2 pi. 500 by pi into 2 pi by 500, which gives you 2:1. Therefore, option C is the right answer. If you see this question, they are given that 4 point loads, that is value of P will be equal to 5000 kilonewton acting at 4 corners of an area, and they have asked us to find out the vertical stress below point M at 5 meters. So the effect of vertical stress at point M, that is the radial distance we need to calculate first, M to P. Since M is at the center of this area, we can take the distance here it as 2 meter and this one is a 2 meter. So we'll calculate the value of here R. So R will be equal to square root of 2 square plus 2 square, which will be equal to root 8, that is 2 root 2 meter. So according to Bosnia's principle, the value of vertical stress at any given point is given by sigma z is equal to 3 by 2 pi 1 by 1 plus r by z square whole power 5 by 2 into q by z square. So vertical stress due to single load sigma z at 5 meters will be equal to 3 by 2 pi 1 by 1 plus r 2 root 2 by 5 whole square power 5 by 2. Q will be equal to 5000 divided by z square, that is 5 square. This one is for single point load. Since in this question they have given 4 point loads, then vertical stress due to all loads. Since all loads are equal, we can directly calculate that equal to 5, which will be equal to 4 into 3 by 2 pi into 1 by 1 plus 2 root 2 by 5 whole square whole power 5 by 2 into 5000 divided by 5 square. So by solving this equation, we'll get vertical stress below 5 meter point M will be equal to 190.8 kilonewton, which is nothing but 190.8 kilopascal. If you see this question and if you see point number 2, Boussinesq theory is used for analysis of stratified soils. Actually, from from assumptions of Boussinesq theory, soil is said to be isotropic. So it is not applicable to stratified soil. Then option B is the right answer, which is not correct. In this question, they have given that the concentrated load of 500 kilonewton is applied to an elastic half space. The ratio of increase in vertical normal stress at depth 2 meter and 4 meter along the point of loading as per Boussinesq equation. So solution, as per Boussinesq equation, the ratio of vertical stress below a certain depth at any point is given by 3 by 2 pi 1 by 1 plus r by z square power 5 by 2 into q by z square. Here they have asked us to find out the effective stress along the point of the loading. So r will be equal to 0, which gives sigma z is equal to 3q by 2 pi z square. So sigma z is by 2 with respect to sigma z equal to 4, which gives 3 by 2 pi into 500 divided by z square 2 square divided by 3 by 2 pi into 500 divided by 4 square. We cancel 500 cancel, which gives you 1 by 4 divided by 1 by 16, which is 16 by 4, that is 4. If you see this question, we'll draw the load distribution diagram for this question, where they have given the rectangular footing. So the dispersed load will be acting like, and they are asking us to find out the vertical stress below 2 meters. This vertical stress below 2 meters according to 2 is to 1 dispersion equation. That is, we'll take 2 is to 1 means we'll take vertical. If we take this slope, vertical will be 2, horizontal will be 1. So that's the ground level. Ground level. So we'll write down the solution. They are given Q equal to 120 kilopascal. Area of rectangle. They have given rectangular footing. So L equal to 2 meter width. L equal to 2 meter, B equal to 4 meter. The equation of vertical stress at any point according to dispersion method, this is given by sigma z dash is equal to Q into B into L divided by B plus 2 NZ into L plus 2 NZ, which gives you 120 into 2 into 4 divided by B, that is 2 plus 2 into 1 by 2 into Z will be equal to 2 into 4 plus 2 into 1 by 2 into Z, that is equal to 2. So the value of n equal to 1 by 2 can be taken from this slope. So n will be equal to slope of this equation, that is horizontal with respect to vertical. So 1 by 2, which gives 120 into 2 into 4. So if we solve this question, if we solve this equation, we'll be getting sigma z dash will be equal to 40 kilo Pascal. If you see this question, they have given that concentrated vertical load of 3000 kilonewton is applied on a horizontal ground surface, and they have also given the depths 1 meter and 2 meter, that is acting along the line of application of load is the key point. Okay, so they have given as per Bossinus equation. They didn't ask us, they didn't given directly to find out using Bossinus method. What they have given, consider the ground to be linearly elastic, isotropic and semi-infinite medium. That is, they have given the assumption of Bossinus equation. So from this we can come to know that we have to find out using the Bossinus theory. And they asked us to find out the ratio of increase in vertical stress at P to the increase in vertical stress at Q. Solution. Since low, they have asked us to find out the vertical stress directly below the line, directly below the point of application of load. So R will be equal to 0. So as per Bossinus theory, sigma z will be equal to 3 by 2 pi 1 by 1 plus R by z whole square, or 5 by 2 q by z square. Since R is equal to 0, which gives 3 by 2 pi 1 by 1 plus 0 by z square, or 5 by 2 q by z square, which gives sigma z is equal to 3 by 2 pi Q by Z square. Now they have asked us to find out the ratio of depths 1 meter and 2 meter. Therefore, Z equal to 1 divided by sigma Z is equal to 2, which gives you 3 by 2 pi. Q is nothing but 5000 divided by 1 square divided by 3 by 2 pi. 5000 divided by 2 square. Cancelling out these terms, we get 1 by 1 divided by 1 by 4, which is nothing but 4 is the right answer. If you see this question, they are given that a concentrically loaded isolated footing of size carries a concentrated vertical load of 1000 kilonewton. So considering Bosnia's theory of distribution, they are asking us to find out the maximum depth of the pressure bulk, corresponding to 10% of the vertical load intensity, which is solution. So the vertical stress acting below the square footing will be equal to, we'll take this as sigma z dash, that is P by A, which is nothing but 1000 divided by A2 into 2. They have asked us to consider 10% of vertical loading intensity. So according to Buzina's theory, so sigma z will be equal to zero point 0.1 sigma z dash, that is 0.1 into 1000 divided by 4. So according to Bosina's theory, we'll keep this one as equation 1. Sigma z will be equal to 3 by 2 pi 1 by 1 plus r by z the whole square power 5 by 2 q by z square. For maximum depth, consider r equal to 0. Therefore, sigma z will be equal to 3q by 2 pi z square. So keep this version as equation 2. So from 1 and 2, 1 is 0.1 into 1000 by 4 equal to 3 into 1000 divided by 2 pi into z square. 1000 gets cancelled. Z square will be equal to 3 into 4 divided by 0.1 into 2 pi. So z square will be equal to 12 by 0.2 pi, which is nothing but 60 by pi. Z will be equal to root of 60 by pi, which is nothing but 4.37 meters. If you see this question, they have given us the equation and they are also given the condition at any given r where there is a variation of sigma z along z. At a specific z, the value of sigma z will be maximum. So what is the locus of maximum sigma z? So if sigma z should be max, then we should consider d sigma z by dz, which will be equal to minimum, that is 0. So Differentiating this equation, d sigma z by dz will be equal to, so we will keep 3p by 2 phi as constant, since we are going to differentiate this part, because that constant is going to do nothing with it. So you can see it is given in the form of u by v. So which is nothing but vu dash. First vu dash vu v will be equal to r square plus z square power 5 by 2. U dash will be nothing but 3z square minus uv dash. U is 3z cube. V dash will be equal to 5 by 2 r square plus z square power 3 by 2 into 2z divided by r square plus z square power 5 by 2 whole to the power of 2. So d sigma z by dz equal to 0, which gives you 3p by 2 pi r square plus z square power 5 by 2 3z square minus 2z power 4 into 5 by 2 r square plus z square power 3 by 2 divided by r square plus z square power 5. So if we take 3p by 2 pi and r square by plus z square power 5 to the left hand side, it will become 0. So we'll take r square plus z square power 5 by 2 into 3z square minus 2z power 4 5 by 2 r square plus z square power 3 by 2 will be equal to 0. So if we take z square and r square plus z square power 3 by 2 as common, we'll get r square plus z square minus, okay, here 3, okay, 3r square plus z square, right, minus 2z square into 5 by 2 will be equal to 0, which gives, therefore 3r square plus 3z square minus 5z square will be equal to 0. 3r square minus 2z square will be equal to 0. 2z square equal to 3r square. Z square will be equal to 3 by 2 r square. Therefore, option A is the right answer. Let us solve all these questions at a stretch. So, for the first question, if you see the graph of water content and maximum dry density for standard Proctor test and modified Proctor test. So this curve will be equal to standard Proctor test and this curve it is modified Proctor test. Therefore, optimum moisture content of standard Proctor test is greater than optimum moisture content of modified Proctor test, and maximum dry density of modified Proctor test is, sorry, maximum dry density of modified Proctor test is greater than maximum dry density of standard Proctor test. So from this, we can conclude that option B is the right answer. So if you see the next question, they've asked us to find out the following which is incorrect. So in these four options, if you see the option D, they have given compaction curve crosses the zero air voids line, but compaction curve never crosses zero air voids curve. So option D is the incorrect one. If you see this question, they have given the recorded SPT value at a particular depth is 28 and they have given the efficiencies. So efficiency is indirectly proportional to number of blows, which is SPT value. Therefore, eta 1 S1 equal to eta 2 S2. So eta 1 will be 50, that is 0.5 into 28 equal to eta 2, 0.7 into S2, which gives S2 equal to 0.5 into 28 by 0.7. 5 by 7 to 28, which gives 20. SPT 2 will be equal to 20. And if you see the last question, they are given that for initiation of quicksand condition, which of the following statement is true? See, if quicksand condition needs to be occur, then the effective stress of soil should be equal to 0. Effective stress of soil should be equal to 0. So both the options they have given the effective stress of soil is equal to 0, and the critical head critical gradient will be equal to the hydraulic gradient. So actually if you see the last option, they have written it as a wrong option. I not equal to IC actually. So from this we can say that option B is the right answer.